Hello everyone. Today I'll walk you through a piece of code that uses something called the Hugging Face Transformers library. It's actually a tool that helps computers understand and generate human language, like writing stories or answering questions. Think of it like teaching a robot to talk or think a little like us. In this code, basically, it generates stories, answers questions, summarizes text, and figures out if a sentence is positive or negative. I'll break it all down step by step and explain what each part does and show you the results it produces. By the end, you will see how powerful and fun this tool is. Let's dive in. So, at the first piece of the code, where we will be installing the transformer library. Okay, consider it. Basically, this line is like going to a library and borrowing a book full of tools for working with language. The Transformers library, created by a company called Hugging Face, is a collection of ready-made tools that does things like write stories or answer questions. So we have installed it. Okay, once we install that particular library, once we install that particular library, the next step, what we will see is, let's make the computer write a story for us. Okay, so let's break this down like a recipe. Okay, first we import two tools from the Transformers library, that is GPT-2 LM head model and GPT-2 tokenizer. Think of the model as a super smart robot brain that can write text, and tokenizer as a translator that turns human words into numbers the robot understands. We load a specific model called GPT-2, which is like a pre-trained robot that's already learned how to write English by reading tons of books and websites. Over here, basically in this line, it's like waking up this robot and its translator so that it does our work. The output here shows the files being downloaded, like model safe tensors, that is of almost 548 MB, which is the robot's brain being loaded onto our computer. Okay. Next, what do we do is, next, we give the robot a starting point. We call it as a prompt. Correct? This is like saying, hey, start a story about a dragon in a cave. The tokenizer turns the sentence into numbers. Okay? Think of this as translating once upon a time into a secret code the robot understands. The written underscore tensors is equal to PT. Basically, this part means we are using a format called PyTorch, which is just a way to organize the numbers. Then we tell the robot to continue the story. Okay, so over here, the max length is equal to 100, means the story can be up to 100 words long, and num underscore return underscore sequences is equal to 1. Basically means we want just one story. The robot thinks and writes the rest of the story. Finally, we translate the robot's numbers back into words. Okay. So now let us look at the output. Let us look at the output. The story repeats a lot. Okay. This is because the GPT-2, the model we used, isn't that perfect. Okay. So the next part would be, let us try another story with a different prompt. Okay. In a land far away, There lived a wizard who. Okay, this is the prompt what we have given. This is similar to the dragon story. We give a new prompt about a wizard. Turn into numbers. Generate a story up to 80 words and translate it back to words. So here is the output. Okay, in a land far away, in a land far away, there lived a wizard who had been born in the same place as the wizard who had been born in the same same place. Again, the model repeats itself. It's like the robot got confused and kept saying the same thing. This shows that GPT-2 sometimes struggles with keeping a story interesting or logical. We could improve this by adding more specific prompts or adjusting settings, like telling the model to be more creative. For example, we could say the wizard cast a spell to guide it better. What do you? Yeah. Okay. So now let us make the computer answer a question like a super smart librarian, maybe. Right? So here we use a tool called pipeline, which is like a ready-made machine that does a specific job. We pick the question answering job. We pick the question answering job and use a model called Distilbert base cased distilled squared. This model is trained to find answers in a piece of text. The context the context is the text we give the model to search for. And yeah, search for answers like a short paragraph about Hugging Face. The question is what we want to know. That is, what does Hugging Face do? Maybe my question is, right? The pipeline reads the context, finds the answer, and gives us the output. This means over here, the values what you could see, score 0.80. Basically, this means the model is 80.9% sure the answer is develops natural language processing tools, which it found in the context. The start and end numbers show where in the text it found the answer. It's like the model highlighted the exact phrase that answers our question. So now let us see the one more section, that is summarizing text, like shrinking a long story into a short version. So this is the code for the summarizing text. We use the pipeline again, this time for summarization purpose, with a model called Facebook Bard Large CNN model. Okay. This model is great at reading a long text and making it shorter while keeping the main ideas. The text we give it is a paragraph about Hugging Face. Okay, we set maximum length is equal to 50 and minimum length is equal to 25 to control the summary's length. And do sample is equal to false, means we want a straightforward summary, not a creative one. Okay. So Hugging Face, it returned as a Hugging Face is an output source software for natural language processing, NLP. It provides tools for text generation, translation, summarization, and questioning answer. So this is nice, a short version of the original text. It captures the key points like Hugging Face makes NLP tools for tasks like text generation and summarization. Okay, it's like summarizing a book report into a couple of sentences. Okay, now let us see one more part, that is sentiment analysis. Okay, so let's see if the computer can tell if a sentiment is happy or sad. Okay, we use the pipeline again for the sentiment analysis as well, which figures out if a sentence is positive or negative. We didn't specify a model, so it uses a default one called Distilbert Base Uncased Fine-Tuned SST to English model. Okay. The text we give is, I love Hugging Face. It's amazing. This means the model is, once we run this particular part, over here we could see label positive and score is 0.99. This means the the model is 99.99% sure the sentence is positive. It's like the computer saying, wow, the sentence sounds really happy. This could be used to analyze reviews on social media posts and much more. Okay, so we have covered a lot of things. We use the Hugging Face Transformers library to write stories, answer questions, summarize text, and check if a sentence is positive or negative. Each part used a different model like GPT-2 for stories or BART for summarize, and the pipeline tool made it super easy to use them. The outputs showed us how powerful these tools are, even if sometimes, like with the repeating dragon story, they're not perfect. This is just the start of what NLP can do. So, thank you.